part, right? Partly there. Each interior angle of a regular polygon is 150, right? We're told that the interior angle is 150. That's I, right? Is 150. How many sides would the polygon have? So if you want to start with the formula, right? The interior angle is n minus 2 times 180 over n, right? So you set it up like that. You multiply both sides by n. Okay, it allows you to cancel out this. So you end up with 150n is equal to, you distribute the 180, so it's 180n minus 360. You bring out the 180n over to the other side, leaving you with negative 360 on the right. You end up with, let's continue here, negative 30n is equal to negative 360. Divide both sides by negative 30. N is equal to 12. 12 sides. So I would give you 2 marks if you've shown everything properly, every single step. You get 2 marks for that one. The second method, I don't know if some of you tried the second method. You figure out that the exterior angle would be 180 minus the interior angle. And so that's 30 degrees, right? So now that you have the exterior angle, you know that the formula for exterior angle is 360 divided by n. You put the 1 here, right? You cross multiply and divide. So n is really 360 times 1 divided by 30, which also gives you 12 sides. Regardless of which method you used, you get 2 marks, okay, for 12. If you just guessed it, you're not going to get the marks there, right? Because I know you can like try numbers until it works out. So you have to show me the steps there. What's the sum of interior angles of a hexagon? Right, the sum of a 6-sided hexagon, right, 6 sides. That would just be 6 minus 2 times 180. That should have been very doable, right? And that is 720 degrees. 1 mark for that. Given the hexagon to the right, what is the measure of angle X? So it is a hexagon. Is this a regular hexagon? No, it's not a regular hexagon. But we still know that the sum of any hexagon will always be 720. Like we know that. We don't need to, it doesn't have to be regular. So what I'm going to do here is I'm going to say that if I go around this hexagon here, which is irregular, right? I can just go, X would just be 720 minus, I'm just going to go around, right? So 120, there's a 90 here, there's a 110, 130, 160. That's it, right? 1, 2, 3, 4, 5, yeah. So you just subtract all of the ones you know from 720, and whatever is left is, so it's 720 minus 610, really it ends up being, which is 110 degrees. So I would give you 2 marks for this. Reason being, right, you needed to know that there should be a 720 somewhere and the 110 as your final answer, right? So regardless of how you did your work, as long as you show it, some of you probably add up all those angles and then subtract it from 720, that's fine. So just remember that, right? Okay. Is the hexagon to the right regular? It's irregular, comma, since the angles are not congruent or the same. The symbol for not being congruent is like this. Never mind the side lengths. It fails the angle test, so it's not regular, right? What is the sum of exterior angles of this hexagon? That's just a fact. That's always 360. It doesn't matter. It doesn't matter how many sides, what, if it's regular or irregular. If you added up all the exterior angles, it's always 360. Okay. In fact, let's do this just as a lesson here. If you go here, the exterior angle there would be 50, right? The exterior angle there would be 70. I'm out of room here, but that would be 90, 60. We now know that this is 70 because we know it's 110, right? So if you were to do that all around and add them up, it should give you 360, right? So 70 and 70 is 140, 260. Wait a minute. So this is 70. So 3 times 70 is 210, 270, and 90 is 360. So it adds up to 360. All right. Backside. Oh, sorry. We didn't talk about the marks, right? So I would say 1 mark for question 6, you explaining it. You should have an explanation following it, and then 1 mark for the 360 at the bottom there. Okay. Backside, true and false. Lines A, B, and C, D are parallel. You look at those, you have a name for them, and they're not the same, so this would be false. Okay. And why? Alternate interior angles are not congruent. Or you just use the symbol, right, that they're not congruent. So because alternate interior angles are not congruent, this does not result in parallel lines. AB and CD are parallel lines, and EH is the transversal. What is the size of EFB, angle EFB, right? So you go EFB, so they're asking for this one right here. We can put a little X there if you want, right? And then say that I'm going to refer to that angle as angle X from now on. So we're going to, on this type of question, I would like you to show your work. So what I'm going to do is I'm going to call this here, sorry. Wait a minute. I'm going to call this Y, and I'd say angle Y is 54, and because their corresponding angles are congruent, right? So I say that this is 54 here because these two are congruent, and we're told these lines are parallel, right? These two. So we can just assume that. And angle X is going to be 180 minus 54, right? And that is 126, right? And I'll just say straight angle is equal to 180. Something like that. If you didn't write down the explanation today, I think I'd be fine because it didn't explicitly say that, but I would say just to be safe, put it down next time. But ultimately, this is what we want, right? So that's 126 for that, for the angle EFB, that is. So I would give you, let's go 2 marks here because you had to do a little bit of work there to figure out the second. Next, PQ and RS are parallel lines. We know that by the markings. TW is a transversal. What's the value of X? We did one of these, sort of, yesterday. So this angle here, I don't have a name for these two, so I want to create a pair that I have a name for, and these two are corresponding. So this angle right here is 180 degrees minus 3x plus 48. My bad, right? But these two are corresponding. So I know that corresponding angles are the same. So x plus 12, this angle right here, is going to be exactly equal to this. Hold on, stop it, right? Does this make sense what I did here? I got this. There's a straight line here, right? So if I know this angle right here can be found by going 180 minus that angle, right? So now I have two pairs. It's just weird. It looks weird, but it is accurate, right? So x plus 12 is equal to 180. I need to distribute this, the negative. Always distribute the negative if it's in front of brackets, right? This is IPR classic, right? Foil, right? And so I bring the 3x over adding, and the x is already here. On the other side, I have 180 minus 48, and this 12 comes over subtracting, right? I bring all the numbers to one side, all the x terms to the other side. That's 4x is equal to, that's 50, 60, so that's 120. Divide both sides by 4, x is equal to 30 degrees. I would say that this would be worth 2 marks. So I would give you, honestly, I would say that you get 1 mark for coming up with this expression here, and then another mark for doing all the work and coming up with the 30. So 2 marks total for that question. Yeah. Okay, so you went x plus 12 plus this is equal to 180. You got the same answer, right? Yes. Yeah. Yes. So there are variations of the way I did it, for sure. Yeah. Okay. I don't know if I want to go too crazy here, but I think where that is coming from, and I see where this angle and these are vertically opposite, correct? So 3x plus 48 goes there. These two are vertically opposite, correct? So let me just erase that for now. If you bring that over, you have x plus 12 here. And so these are consecutive interior, which add up to 180. You should get the exact same answer. So this plus this is equal to 180. You get the same answer. All right? Yeah, way to go. If you saw that, you're good to go. Way to go, teacher, making it complicated, right? Why didn't you just do this, right? Sometimes that's just how it is, but that's good to see that other students are trying it differently. All right, so 2, 4, and so this back side is 5, right? The back side is worth 5. The front, 1, 2, 3, 4, 5, 6, 7, 8. The front is worth 8. So 8 and 5, we're out of 13 here. Total out of 13. So put your first name and last name, pass it forward, and get your booklets out, okay? Those, the note package that I gave you. And I'm going to get you to go to page 16. Page 16, I believe. Inscribed. Okay, so we're going to be talking about page 16, okay, in your handouts. Everybody has that one, right? I have only one copy left, so I'm not sure if I miscounted when I copied or. So this is taking it. This is bringing everything together. Everything you've learned all comes together here. So I'm just gonna take one moment. I used to have a smart board in my previous school, so I love the software for certain things. So just imagine, any polygon that you can think of, right? So let's take a heptagon here, right? You know how to find the interior angle, the central, the exterior. You know all of that. You have formulas for that. What do you need before you start? You need to know the number of sides, right? Always focus on that part because these diagrams, they will have 0 angles given. You will know none of them. And so you need to start with that. You need to use those formulas to get you. And the most important of them will be to find the interior angle first and foremost, right? And what I will start, or what you will start seeing, is that there will be diagonals drawn inside. So for example, I could introduce this one here, right? And the question might ask you to find, it might ask you to find that one right there, A, which we know is the interior angle of this big polygon here. But then you might also want to know what is that angle right now that was formed, right, between that diagonal I just introduced and the outside of this polygon. So what would that be? Well, the fact is that this here is, you could see a triangle, and it's actually what kind of a triangle? If it's a regular polygon outside, you actually have an isosceles triangle here. And so we know how to find this one because as soon as we have that one there, when you find A, which is the interior of this whole polygon, right, we know that one. And so we can easily find these two because they're going to be exactly the same. On the other hand, I could also add another diagonal. Let's say I do one of these here, right? And I would ask you, hey, what's this angle right here? Let's call that C, right? Well, if you look carefully here, this shape produced here is called, anybody know what the name is of this shape right here? Of this one? Trapezoid? Have you heard of a trapezoid? It's been a while maybe, but you have that there. It's actually an isosceles trapezoid as well. And there's something cool about anything that has isosceles attached to it, makes it a lot easier for us to find things. So that's what we're going to learn. We're going to introduce diagonals in there, and then we're going to find the angles that result from these diagonals being introduced. I could also do one of these. I could add even more. I could connect this one with this one there. And what do you see? This line right here is probably parallel to this line right there. So this diagonal is now also a transversal. And you're like, no, right? It's too much. I can't handle it. Well, we'll walk you through it step by step. But it all comes together here, okay? So I just wanted to show you that before I start the journey, okay? So page 16, often questions will have polygons with diagonals in them, okay? Which create inscribed, right? Inscribed is like written inside, basically. Inscribed shapes, and the most common are this one here, right? And in this case, you have, this is the diagonal here. And you have like an isosceles triangle up there. You also have a trapezoid down here. Okay, so that one right there, it's an isosceles triangle. Okay, and the one down here, which is created by the same diagonal. It's called an isosceles trapezoid. Okay. How many sides does a trapezoid have? 1, 2, 3, 4, right? 4 sides. That's worth mentioning. That one has 3 sides, right? And then look at this other one here. Hold it. Hold it. One more. Let's focus on the outside first. This is what I want. This is what a lot of students will miss. They'll miss the fact that, hey, first and foremost, we're talking about a polygon here, which is the number of sides would be 5, right? Okay. That is the first thing I want you to check out. And then I want you to focus on the diagonal and the shapes that result from it, right? But focus on the outside first. I will highlight that green there because then you're focusing on the outside. Now let's go to this one here, right? I will say, hey, let's focus on that polygon, right? That where everything else is found inside, right? So you count 1, 2, 3, 4, 5, 6, 7. N is equal to 7. Very important. N is equal to 7 sides, right? And so 7 sides is what we start with. And then this one just has one diagonal. Okay, this shape right there is a trapezoid. And actually, sorry, it's an isosceles trapezoid. Because the only way these questions work is if I give you a regular polygon, right? So all the sides will be the same. What do you have down here? Like the second shape created. If you look at the bottom of the diagonal, how many sides does this one have? 1, 2, 3, 4, 5, right? If you count the diagonal. So this is actually a pentagon. But not any kind of pentagon. It's the isosceles pentagon. I have a lot of highlighters, so I could go crazy with highlighters there, but I'm not going to. I hope you see them, right? When I just make an arrow in there, I'm talking about this one being a pentagon. This is a trapezoid. Triangle, trapezoid, right? So I hope this builds the case for what you're going to see next, okay? All right, so isosceles triangle. Basically, what I want you to focus on is B is going to be found by going 180 minus angle A, right, divided by 2, okay? And let me just check if I will just make a note down on the side here where A is the interior angle of the main polygon. Okay, it's very important. So A, I will highlight, and I will highlight it there as well, and maybe also in the triangle. Okay. So perhaps just make sure that don't worry about the letter A in and of itself. Just make sure that this is the interior angle. It's the interior angle of the main polygon. Can we do this? I know you can do this. It won't mess it up too bad, right? Just capital I right next to it, right next to interior angle. I'm trying to make sure that when you look back that you know what I'm referring to. So if there's an isosceles triangle, this formula is going to come in very handy. Next, isosceles trapezoid. If you see a trapezoid there, to find these angles here, instead of 180, a four-sided shape has a sum of 360 degrees. So you will subtract. How many A's need to be subtracted? How many interior angles? There are 2, so you got to go minus 2 times A over 2. And there's something actually that I'm going to add. Just highlight A here everywhere. One thing that a lot of students that I notice a lot of mistakes because they type it in all in one shot. If you type it in one shot, you better do this. The top, if there's ever operation happening in the numerator ever, there are invisible brackets there technically. So you need to make sure you put that in brackets, okay? So that's your trapezoid. That's how you would find these base angles. Emphasis on the fact that you subtract 2 interior angles there. Then you have the isosceles pentagon. And anybody remember what the sum of angles is in a pentagon? Did you do the chart for homework on page, what page was it on? I made you fill in that chart. Right now, I don't know where that chart is. 540, right? You see it? 540? What page is that? 13, thank you. So on page 13, we recognize that, and just use the formula if you forget, the sum of interior angles, but it's always 540 for a pentagon. And we would have to subtract these 3 angles that would be known to us. You will be able to find the interior angle of that big polygon, right? So it's 3 times A divided by 2. You always divide it by 2 to split the difference between the 2 base angles there. So I'll put my brackets there. I will highlight that. And now I'm going to just add one more thing on this page here. And I hope this won't make it too messy. But just say that the interior angle of any pentagon is n minus 2 times 180 divided by n. Okay. And I'm going to have arrows going to all of the A's in all of our formulas, right? So this one, I'll say it goes in there, goes in there, and it goes in there. Okay. So that is the interior angle of that big outside polygon that everything is inside of. Okay. And now that we have this out of the way, we can actually do some calculations. Yeah, you probably would want this on your study sheet. I don't know if you need a diagram that goes with it, but Here it is. So this is page 17 here. It's 17, right? You have this? Okay. This one right here. So first, they're asking you to calculate A, B, C, right? So I will first focus on the outside, right? Focus on that first. Don't worry about the inside just yet. And you count 1, 2, 3, 4, 5, 6. So n is equal to 6 sides, which we know is called a hexagon. Okay. Coincidentally, this is just coincidence. This could have been called x for all we care. That happens to be, this angle right here is actually the interior angle of this hexagon. So angle A, to find it, I'm going to use this formula. I is equal to I of n, sorry. I can just go, I don't have to write out the formula, right? I think you should know by this point. An interior angle of a 6-sided shape would be 6 minus 2 times 180 over 6. And that is actually 120 degrees. So angle A is equal to 120 degrees. I'm done with that. Okay. Now I'm going to, and you decide, sometimes one is better than the other, but go ahead, and if you focus on this triangle here, you should be able to put in the 120 up here. Okay, and this is an isosceles triangle. We can make these markings all around the hexagon, but if you focus on this triangle, right, angle B, that's where I'm going to do the work here. There's an isosceles triangle here. So if I want to find angle B, all I have to do is I have to go 180 minus that angle up there, which is 120, and then divide the rest by 2. Okay, 180 minus 120 is 60. Divided by 2, that's 30 degrees. And so angle B is worth 30 degrees. Measures 30 degrees. That's that for B. What about angle C? How could I find angle C? That one I would expect you to know how to answer at this point. How would you be able to find C here? Focus on, if you connect this side of the polygon and this side, that whole thing is the interior angle, right? Which we know is 120. So it's 120 degrees minus, I'm going to take away angle B. So I will first show that that's what I'm doing here. Okay, I take the interior angle, I subtract angle B, which is up here, and that will give me angle C. So it's 120 minus 30, and that happens to be 90 degrees. Okay, so angle C is 90. Okay. What shape do you have on this side? 1, 2, 3, 4, 5, right? That's actually an isosceles pentagon. But there's no need to work with it, right? Like if they're right next to each other, it's probably easier to just work with a triangle and find this, because if this is 90 here, what do we know about this angle out here? If it's an isosceles pentagon, we also know that this will now be 90. These are two 90s. And so there you have it. Okay, cut this. Let's try one that is probably going to be a bit more challenging here. You're like, wait a minute, seems to be going outside of the shape, the polygon that I see. Yes, but for now, let's focus on this one right here. Focus on that one right there. So let's count the number of sides. 1, 2, 3, 4, 5, 6, 7. N is equal to 7. That actually, we know, we have a name for it, heptagon. And so now you have to choose, right? What am I going to do first? I would find a corner of the big polygon right here and solve for that first, because that's the interior angle. So angle X, right? I'm just going to find the interior first. Sorry, I of 7, sorry, is 7 minus 2 times 180 over 7. That'd be 5 times 180 over 7. And that is actually a decimal. I think it's 120 something. I forget. Yeah, 128.57. Okay. So therefore, angle X is 128.57. So now I'm going to focus on the diagonal, and there's angle Y and there's angle Z. Which one would be easier to find? To me, they're actually about the same. But on this side, you have 1, 2, 3, 4, 5. It's a pentagon. On this side, you have a trapezoid. So I think I'm gonna start, for illustration purposes, I'm gonna find this one, okay? Just for today. So angle Z, right? I'm gonna just say it's an isosceles pentagon. Pentagon should tell you, okay, the sum of all interior angles of this shape right here created by that diagonal is going to be 540. Okay, so angle Z is going to be found by going 540 minus, there are 3 angles at the top, like you almost have to consider this the base. At the top, you've got 3 angles that are 128.57. These are like the 3 that are on top on the diagram before this, right? So minus 3 times 128.57. And then you're going to divide that remainder in half. Let's see here. I think I have enough room to just go angle Z down here. I'm going to go 540 minus 3 times 128.57. That's 154.29. It takes an extra second to actually split that up, right? 77.15 degrees. So angle Z, I like to have that stated like this, right? 77.15 degrees for this angle right there. By the way, this is 77.15 and that is 77.15. They're both, so you found them both, but it's just asking you for this one, right? So that's that. I'm going to cut that there. Now, angle Y, you have a choice. I'm just going to go like this. Angle Y is going to be 128.57, which is the whole thing. The whole thing where Y and Z meet, that whole thing is 128.57. I'm going to subtract angle Z from it. Let me just bring that up a bit for you there. And so angle Y is 128.57 minus 77.15. 51.42. And here, I want to at least give you the option, right? Or angle Y, there's an isosceles trapezoid. Like on this side of the diagram, there's an isosceles trapezoid. So to find angle Y, I could have said, well, a trapezoid adds up to 360. I'm going to subtract. How many angles do I have to subtract when I use the trapezoid? There's one here, and there's another one there, right? So I have to subtract 2 of the 128.57s, and then divide that by 2. And I promise you that it's the same. You get 102.86 divided by 2, which is 51.43. But it's not the same. We're off, right? That's going to happen. You're off by 0.01. We're not sweating it, right? If I will recognize that, and it's just because of the rounding that we perform. Okay. So either way, using the trapezoid or just using the fact that both angles that meet at that interior angle add up to 128.57. So it's just a subtraction there. How's this? Yeah, it's pretty fun. Once you know how to do it, it's fun. So I would like you to try, there's page 18, but I was going to try this one, question C on page 18. Give that one a try. See if you can do that one. Our workbook, right? I want you to try these questions. So on tomorrow's quiz, there will be something like this on there as well. Okay. If you want the answers, they're up here. I just